Hello everyone, at lecture 15 we will continue in determinant and linear system, and here we have Cramer's rule to solve linear system using determinant. So if I have here system of a1 x plus b1 y equal to c1 a2 x plus b2 y equal to c2, then using Cramer's rule, x will be equal to n x by d. Here y equal to n y by d. Okay, and here n and d refer to numerator and denominator. Okay, and here to obtain d equal to a1 b1 a2 b2, here nx equal to c1 c2, here b1 b2, ny equal to the determinant of a1 a2 c1 c2. Okay, just in nx and ny replace the coefficient of x, okay, by free term, and here replace coefficient of y by free term. Okay, so from here x will be equal to value of nx c1 b2 minus b1 c2 by the value of denominator d, here a1 b2 minus a2 b1, and y equal to here a1 c2 minus c1 a2 by a1 b2 minus a2 b1. Okay, okay, let me take this example. If I have here system of linear equation 3x plus 5y equal to 21, and here negative x plus 3y equal to 7. Okay, so here d will be equal to 3, 5, and here negative 1, 3, and 4, and x will be equal to, replace the free term 21, 7 by coefficient of x, and here 5, 3, 4, and y. Here we have 3, -1. Replace coefficient of y by 3 terms. So we have here 21, here 7. From here, if we ask to solve this linear system, so we have here x will be equal to here 21 into 3 minus 5 into 7 by value of d. So we have here 3 into 3 minus we have here plus 5 into 1. Okay, here y equal to 3 into 7 minus so we have here plus 21 into 1 by d 3 into d plus 5 into 1. We have here we have 3, we have here 35, and we have here 9, we have here 5. So here x will be equal to here 28 by here 14 equal to 2. Okay, and y equal to here we have 21, so we have here 42 by here 14 equal to 3. Okay, we just get x and y by substitute with values of denominator, values of numerator of x and y. Okay, so let me clear this. If we have linear system of 3 equation, so we have here a 1 x plus b1 y plus c1 z equal to b1, here a2 x plus b2 y plus c2 z equal to, sorry, we have here d1, here d2, again a3 x plus b3 y plus c3 z equal to d3. So from here again x will be equal to n x by d, here y equal to n y by d. Okay, z will be equal to nz by d, and here nx, ny, nz and d will be determinants of order 3. So here we have just enlarge z, d here equal to determinant of coefficient. So we have here A1, A2, A3, B1, B2, B3, C1, C2, C3. Here we have just an x equal to replace coefficient of x by three terms. So we have here D1, D2, D3, B1, B2, B3, C1, C2, C3, and y equal to here A1, A2, A3. Replace coefficient of y by three terms. So we have here D1, D2, D3, here C1, C2, C3, and Z. Okay, similarly, we have here A1, A2, A3. Here we have B1, B2, B3, and here replace coefficients of Z by three terms. So we have here D1, D2, D3. Okay, so just here, if we have this system of x here, x plus 3y plus 2z equal to negative 13, here 2x minus 6y plus 3z equal to 32, here 3x minus 4y minus z equal to 12. Okay, so just we have here, okay, here x equal to nx by d. Okay, and here d will be equal to coefficient of x, y, and z. So we have here 1, 3, 2, here 2, negative 6, 3, here 3, negative 4, negative 1, and 4, and x. We have here just replace three terms here by coefficient of x. So we have here negative 13, 32, 12, here 3, negative 6, negative 4, 2, 3, negative 1. Okay, and y equal to n y by d. Here y will be equal to here 1, 2, 3, negative 13, 32, 12, here 2, 3, negative 1, z equal to n z by t. Here we have 1, 2, 3, 3, negative 6, negative 4, replaced by three terms. So we have here negative 13, 32, and here we have 12. Okay, the values of nx, ny, nz, and d just here. We have D will be equal to 1 into here 6 plus 3 4 here minus 3 into negative 2 minus 3 and 3 here plus 2 here we have negative 4 and 2 plus here 3 and 6. So we have here this equal to 18. This equal to here we have plus here negative 11. So we have here plus 33. Okay, and here we have here. Okay, here we have 8. So we have here plus 20. This will be equal to 71. Okay, for nx equal to here we have negative 13 and 2 here 6 plus 3 and 4 here minus 3 and 2 here we have negative 32 minus 3 and 12. Okay, plus 2 and 2 here 32 and 2 negative 4 plus 6 and 2 12. So this will be equal to this 3 12. So we have here 10. We have here negative 2 34 and here we have okay. So we have here 68. We have here plus 204. Here we have negative 128 and here we have 72. So we have here minus 112. So this summation will be equal to negative 142. Okay, again with ny. Okay, and here n z, this will be equal to 1 and 2 negative 32 minus 36 here plus 13 and 2 negative 2 minus 9 here plus 2 and 2 24 minus 96. So this will be equal to negative 355. Again with nz, that's equal to 1 and 2 negative 72 plus 128 here minus 3 into its minor. We have here 24 minus 96. Okay, here minus 13 into its minor. So we have here negative 8 plus 18. This will be equal to here 142. Okay, so just I make the calculation of determinants of order 3 by multiply of element into its minor. Okay, so just we can get the values of all determinants. Okay, just clear and calculate values of here x, y, and z. We have here okay x equal to nx by d. So x equal to negative 142 by 71. So this equal to negative 2. Here y equal to n y by d. This equal to negative 355 by 71. So this will be equal to negative 5. Here z equal to nz by d. So this will be equal to 142 by 71. So this equal to 2. Okay, we just get values of x, y, and z by here Cramer's rule. Okay, just clear and move to another example on Cramer's rule. Another example on Cramer's rule. If we have this linear system of 3x minus 2y minus z minus 4w equal to 7, x plus 3z plus 2w equal to negative 10, x plus 4y plus 2z plus w equal to 0. Here 2x plus 3y plus 3w equal to 1. Okay, so here we have linear system of order 4. So from this we have here x equal to nx by d. Here y equal to ny by d. Z equal to nz by d, and w equal to nw by d. Okay, determinant of d equal to here the coefficient of x, y, z, and w. So we have here 3, 1, here 1, 2, negative 2, 0, 4, 3, -1, 3, 2, 0, -4, 2, 1, 3. Okay, so we can get the value of this determinant by using here theorem 3. Okay, so we just can convert this determinant to a determinant of order 3, so easily we can obtain its value. Okay, so any row or any column we can convert it to element equal to 1 and then other element equal to 0. So by evaluate this determinant we can use just the element 1 into its minor. Okay, and its minor in this case will be equal to determinant of order 3. Okay, so just if we look here, we have here element 1, so easily we can convert it 3 into 0, 2 into 0. So operation here is to multiply first column by -3, then add to third column, again multiply first column by -2, then add to fourth one. Okay, so we have here first column as this, multiply first column by -3, then add to third column. Here we have 0, so no need for any operation, so just rewrite it as it is. 3. Here multiply 3 by -3, then add to -1, we have here -10. Multiplied 1 by -3, then add to 3, we have here 0. Multiplied 1 by -3, then add to 2, we have here -1. Multiplied here 2 by -3, then add to 0, we have here -6. Okay, again multiplied 3 by -2, then add to -4, we have here -10. Multiplied 1 by -2, then add to 2, we have here 0. Multiplied 1 by -2, then add to 1, we have here -1. Multiplied 2 by -2, then add to 3, we have here -1. So we just here obtain our row. So we can evaluate the determinant by using this row and element 1. So just we can here write down signs of element. We have here plus, minus, plus, minus, here minus, plus, minus, plus, here plus, minus, plus, minus, plus, plus, minus, plus. Okay, so element 1 has negative sign, so we just here can write negative sign, and to its minor we have its minor here -2, -10, -10, 4, -1, -1, 3, -6, -1. Okay, so if I calculate the value of this determinant, we can obtain d here equal to negative, and to here -2, and to 1. Here we have -6. Okay, so here we have 1 minus 6, here plus 10, into -4 plus 3, here minus 10, into negative 24 plus 3. Okay, this into negative sign. So this calculation we will obtain the equal to negative 210. Okay, so let's move to nx. So just t equal to negative 210 and move to nx. We have here just replace the coefficient of x by three terms. So we just have here 7, negative 10, 0, 1, and other coefficient negative 2, 0, 4, 3, negative 1, 3, 2, 0, negative 4, 2, 1, 3. Okay, so as we did before, we just can calculate this by converting a row or any column into element of 1 and other elements are zeros. Okay, so we just here this element 1, so we can convert here 3 into 0, 3 into 0. So our operation here is to multiply first column by negative 3, then add 2 second 1, multiply first column by negative 3, then add 2 for 1. Okay, so we have here just 7, negative 10, 0, 1, multiplied 7 by negative 3, then add to negative 2. We have here negative 23, multiplied here negative 10 by negative 3. We have here 30. Here we have 4, multiplied this, we have 0. Here no need for any completion. 0, okay. Multiplied 7 by negative 3, then add to negative 4. We have here negative 25, multiplied negative 10 by negative 3, then add to 2. We have here 32. Multiplied 0, we have here 1. Multiplied, we have here 0. Okay, so we just here obtain our row. Okay, so just write down our signs to obtain the sign of here. The sign is negative sign. Okay, so we just write down here negative and write down the minor of this element. We have here negative 23, 34, negative 1, 3, 2, negative 25, 32, 1, and here nx equal to negative, negative here into 3 minus 64 plus 1 into 30 here minus 128 here minus into 60 minus 12. Okay, this will be equal to negative 105. Okay, so we just obtain the value of nx. Just move to another one. Here we have nx equal to negative 105. Okay, move to n y. Okay, so we have here n y will be equal to coefficient of x 3, 1, 1, 2. Replace coefficient of y by 3 terms, so we have here 7, -10, 0, 1, -1, 2, 3, 2, 0. Here we have -4, 2, 1, 3. Okay, so again we have here row with element 1, so just we can replace 2 by 0, 1 by 0. So our operation here, as we did before, just multiply first column by -2, then add to third column. Multiplied here first column by -1, then add to fourth column. Okay, so we have here 3, 1, 1, 2. Second column as it is, so we have here 7, -10. Here we have 0, 1, 3 into -2 minus 1. We have here -7. Here 1 into -2. Here we have 1. 1 into -2 plus 2. We have here 0. 2 into -2 plus 0. We have here -4. Here first column by -1, then add to fourth one. So we have here -7. Here we have 1, 0, here 1. Okay, so thus we obtain row. Okay, just we can here determine sign of this element n here by this rule, this element in first column and in third row. So we have here positive sign, so just here write down its minor. Here we have 7, -10, 1, -7, 1, -4, -7, here 1, 1. Okay, so here ny will be equal to here 7 and 2, 1 plus 4 plus 7 and 2, -10 minus 1, here minus 7 and 2, 40 minus 1. So this will be equal to -350. Okay, so just we obtain n y move to n z. Okay, we have here n y equal to -315 and move to nz. We have here nz equal to 3, 1, 1, 2, -2, 0, 4, 3, here 7, just replace 0, 1, and here -4, 2, 1, 3. We have here this element equal to 1, so we can just here make our operation. So we have here 4 will be converted into 0, here 1 convert to 0. So here our operation is to multiply first column by -4, then add to second column, multiplied here first column by -1, then add to fourth column. Okay, and no need for any operation in this column. Third one, we have here 3, 1, 1, 2. Here we have 3 into -4 minus 2. So we have here negative 14. Here we have 1 into negative 4, so we have here negative 4. Here 0, 2 into negative 4 plus 3, we have here negative 5. Here 7, negative 10, 0, 1. Here we have 3 into negative 1 minus 4, negative 7. Here we have 1, 0, 1. Okay, so just we have here our row, and this element have a sign of here negative 1 first column plus third row. So here we have positive sign, so just write down at minor negative 14, negative 4, negative 5, here 7, negative 10, 1, negative 7, 1, 1. Okay, so nz equal to negative 14 and 2, negative 10 minus 1, here minus 7 and 2, negative 4 plus 5, here minus 7 and 2, negative 4 minus 50. So this will be equal to 5, 25. Okay, and this is the value of nz. So just we have to clear that and move to n w, the last one. So we have here n z equal to 5, 25, and for nw we have here 3, 1, 1, 2, negative 2, 0, 4, 3, negative 1, 3, 2, 0. Here we have 7, negative 10, 0, 1. Okay, so just here we have n second column, we have here this element equal to 1, so we just may start from here. So our operation is to multiply first column by negative 3, then add to third column, multiply first column by 10, then add to fourth column. Okay, so we have here 3, 1, 1, 2, here negative 2, 0, 4, 3, here multiplied by negative 3, then add to negative 1, so we have here negative 10, multiplied here by negative 3, then add to 3, we have here 0, multiplied by negative 3, then add to, we have here negative 1, multiplied by negative 3, negative 6. Okay, and here we have to multiply by here 10 into first column, then add to fourth column. We have here 3 into 10 plus 7, 37. Here we have 0, here 10, and here we have 21. So just we have here our row, and here sign of this element in first column and second row. So here our sign is negative, so here we just put negative here and start to put our minor negative 2, negative 10, 37. Here we have 4, -1, 10, 3, -6, 21. Okay, and this NW equal to negative N2 here, negative 21 plus 60 here, plus 10 N2 here, 84 minus 30 plus 37 N2. Here we have negative 24 plus 3. Okay, this will be 150, 15. Okay, so this is NW, just clear. So after all this operation, we have here x will be equal to here negative 105 by negative 210. So we have here x equal to 1 half. Here ny equal, sorry, y equal to ny by d. So here y equal to negative 315 by negative 210. We have here 3 half. Okay, and here nz equal to 25 by negative 210. So we have here negative 5 half. Okay, and for w equal to nw by d will be equal to here 315 by negative 210. So we have here negative 3 by 2. Okay, and we can verify this by using any of this equation. So here we can substitute by x, y, z, and w in first. So substitute in first one. So we have here 3 into 1 half. Here minus 2 into 3 half minus here will be plus 5 half minus will be plus here 4 into 3 half. This will be equal to here we have 6. Here we have negative 3, and here we have this with this will be equal to 4. Okay, so this will be equal to 7. Okay, I hope this is clear. Sometimes we proceed many calculation, but this is just systematic calculation to obtain here x, y, z, and w by Cramer rule. Okay, so just let me clear that and move to last point in our lecture of nature of our solution, nature of solution of linear system. Here we have four cases of solution. Case 1, if the denominator doesn't equal to 0, then the system has unique solution. Okay, has our system has one solution of x equal to y equal to z equal to w equal to. Okay, case 2, if d equal to 0 and d here will be equal to 0. Look at theorem 1. If two rows or two columns are identical, then the value of denominator will be equal to 0. Okay, and at least one of nx, ny, nz, and nw based on here the order of denominator or the number of unknowns in our system doesn't equal to 0, then the system has no solution. Okay, so if d equal to 0 and here nx, ny, nz, and nw doesn't equal to 0, then here our system has no solution. Okay, case 3, if d equal to 0, okay, and up to m minus 1 number of nx, ny, nz, and w equal to 0, then system has infinite solution. Okay, so here d equal to 0, and here if I have system of 4 order 4, so nx, ny, nz equal to 0, then system has infinite solution. Okay, and here only nx can be 0, only ny can be 0, only nz can be 0, or ny and nx or all three. Okay, but if all of this equal to 0, then we have here already homogeneous system, and here we called our solution as trivial solution. Okay, here for case 4, for the system of homogeneous equation has a trivial solution if d doesn't equal to 0, or has infinite solution if d equal to 0. And here homogeneous system represented by this equation here: ax plus by plus cz plus tw equal to 0. Okay, so here if d doesn't equal to 0, then this system has a trivial solution. Okay, and here if d equal to 0, then our system has infinite solution. Okay, you can check any system of linear equation, okay, of these four cases. Okay, I hope this chapter of determinants and linear system is clear. Okay, we talked here about definition of determinants and the properties of determinants which related to these theorems. Okay, and we use these theorems to get the value of any determinant. Okay, and here we move to Cramer's rule, which used to get the solution of linear system. Okay, and here we have nature of solution of nature of linear system. We have here case 1, case 2, case 3, case 4 of homogeneous equation. I hope this lecture is clear and thank you.